Alrighty. So today we are talking about air pollution. So some of this you may have interacted with before, or may not have. That's totally fine. So today is all about air pollution. Tomorrow is about what we have done to control air pollution. There will be some sort of activity on Friday. And then tomorrow, next week, like I said before, we have a couple days of review and then we test. So just be cognizant of that. So my goal for you for today is to be able to. You can barely see that blue. Okay. Is to be able to explain what causes air pollution, how that pollution may affect human health, and talk specifically a little bit about smog and how temperature affects it. And we'll wrap up with some acid rain information. So that is today. Does anybody have any questions before we get started? All right, stop me if you do. Starting off, okay. What is air pollution as a whole? We talk about air pollution a lot, especially in especially now, as air pollution and climate change kind of become bigger and bigger issues as time progresses. But we don't really have most of the time a definition. We just kind of have a general idea. So air pollution is the release of damaging materials into the atmosphere. So this could be damaging to human health. This could be damaging to environments. This could be damaging to buildings. Anything that is released into the atmosphere that can cause something damage is considered an air pollutant. So even though there is carbon dioxide in the atmosphere, too much carbon dioxide can be a bad thing. And at that point, carbon dioxide becomes a pollutant when it is released into the atmosphere. These substances that are released are called emissions. So when people talk about greenhouse gas emissions, greenhouse gases are a pollutant that is released into the atmosphere or emitted. And emissions can be gases, but they can also be very, very small particles. And those very, very small particles are called particulate matter. Particulate matter. So, let's see. Asbestos isn't necessarily like a wide air pollutant, but it is something that is very, very small particle-wise that when inhaled is really, really, really bad. That could be considered particulate matter. So things like burning coal and stuff like that can release small particles of not necessarily gas, but like powered enough to get up into the atmosphere and stay there. So those are considered particulates and are a specific type of emission. So gas or solid, it doesn't matter, as if it is released into the atmosphere and stays there, and that is damaging, it is considered air pollution. So I can't throw a fistful of sand at you and see that some of it hangs in the air and say that it is damaging. Therefore, it is a pollutant because it's not going to get like up there, and it eventually will settle. So that is a definition of air pollution. Do you have any questions? All right, if I go too fast, let me know. So there are two big sources of air pollution: natural processes and human sources. So usually when we think about air pollution, we think about what humans do, mainly because we can control what humans do. So if something humans do causes pollution, we can more easily put a stop to it. But there are natural processes that cause air pollution as well. Volcanic eruptions are considered air pollution because all of that dust and smoke and carbon and sulfur uh, all uh, make their way up into the atmosphere. Um, in fact, a lot of people think that life on Earth or human life on Earth will end because of air pollution emitted by a supervolcano, because it will just speed up the process of climate change altogether. Um, there are a lot of like sci-fi natural disaster movies about that. Smoke from a wildfire is also considered air pollution, especially if that wildfire it goes beyond what it naturally would be. But that smoke is released up into the atmosphere and causes some damage. Dust storms are also a source of natural air pollution, which is worsened, of course, by erosion. So when humans interact with that, they can kind of inadvertently contribute to natural air pollution. But humans also majorly influence air quality, um, mostly through the burning of fossil fuels. So we talk about fossil fuels a lot when we talk about air pollution. A fossil fuel is a carbon-containing fuel that formed millions of years ago from the remains of living things. So, what on earth does that mean? We are carbon-based life forms. So remember back way back to the beginning of the year, we talked about biological macromolecules and like all of the stuff that our bodies are made of. Carbohydrates, proteins, lipids, nucleic acids. All of those are based in carbon. Um, whenever we talk about organic versus inorganic organic things contain carbon. So even though, or all life, not just human life, all life is considered to be carbon based. And the same was true millions and millions of years ago with like dinosaurs and the plants that were around with the dinosaurs. Um, but when that organic matter was buried, um, the pressures of the earth kind of compressed that organic material until it became this oil stuff that we have now tapped into and used for energy. Um, so fossil fuels are carbon-containing fuels that were formed millions of years ago from the remains of living things. Um, so every time you put oil or gas in your car, um, you have a lot of uh, decayed organisms. Thank you for that. Unless, of course, it's synthetic and then, well, that's a whole other. Anyone have any questions about natural air pollutants or human-caused air pollutants? All right. So there are also there are different ways to classify air pollutants. Um, so not just like human caused and naturally caused. We also have primary and secondary pollutants. So a primary pollutant are pollutants that are released directly into the troposphere that can cause damage themselves or react with other pollutants to cause damage. So things like soot, carbon monoxide, particulate matter, sulfur dioxide, all of those can directly cause harm to human health. And when they are released directly into the atmosphere, they are considered primary pollutants. They can cause damage themselves, or they can react with other pollutants uh, up there to create something damaging. So our primary air pollutants in the United States, based on this little chart over here, You can see most of them are carbon monoxide and particulate matter. I'm trying to think. Oh no, I totally did it. Okay, you're fine. So mostly carbon monoxide and particulate matter. We've got a decent percent, so 9% of our volatile organic compounds, about 10% of nitrogen oxides, 8% sulfur dioxides, or oxides, I guess. Um, but most of it is between carbon monoxide and particulate matter. And usually that's due to like industrial processes and motor vehicles. Uh, Cars cause a lot of air pollution, and we'll talk about how, as well as how we have addressed those pollutants in the past. Soot is kind of like a catch-all term. Usually it's like burnt particles from stuff. Um, so like if you were to, oh, if you've ever like lit a candle, right, and then the side of the candle jar starts to turn black, that would kind of be what soot is like, because those particles, when not stuck to the side of the glass, are released into the air, but on a much larger scale. Those are primary pollutants. Where there are primary pollutants, we also get secondary pollutants. So, secondary pollutants are harmful products that are produced when primary pollutants chemically react with one another. So, not all of the things in the atmosphere that cause us harm were what we released up there, but we weren't necessarily keeping track or controlling what we released up there. So, it can connect with some other stuff that's up there, um, and react to combine or react to create something new. Things like tropospheric ozone, sulfuric acid, and nitric acid are all things that cause a lot of damage down on Earth, and are uh, I lost the back half of that sentence. Sorry. Okay. Just rebooted. Um, so these things, specifically sulfuric acid and nitric acid, can cause a lot of damage on Earth, in things like acid rain, which we will talk about. But they weren't what we released into the atmosphere. What we released, those primary pollutants, will come together, interact, and create these secondary pollutants. So they're kind of like byproducts of what we had. Tropospheric ozone. We are specifically talking about tropospheric ozone because stratospheric ozone is important. We want ozone in our stratosphere because that stratospheric ozone is what protects us from UV radiation. It is when that ozone is in the troposphere, so down a level, that it becomes an issue. So, stratospheric ozone, good. Tropospheric ozone, bad. Um, so, that's primary and secondary pollutants. Talking about human health is very important um, when we are interacting with air pollutants because they can very directly cause issues. We talked about, which one do I want to go with? When we talked about soil resources, right? When soil resources got polluted, it took a couple steps before it affected human health. Something had to be grown in that polluted stuff, or something couldn't grow in that polluted soil. and that is how humans were affected. But air pollutants are directly taken in, so they can cause a lot of damage. Specifically with the respiratory system, it can also interfere with the body's uptake of oxygen, and I'll talk about that, and cause cancer, both in the respiratory sense and in the increased amount of radiation reaching the Earth sense, which I will also talk about. You can't see this blue thing. Like, anyway, so we will have a couple slides dedicated to how um, air pollution can affect our lives. So, starting us off with the respiratory system. So, when we, if you've ever just like been cleaning something that's really, really dusty, and all of a sudden you just can't stop coughing, or if you go clean out something and you're interacting with a lot of dirt and dust, and then like for days after the fact you just can't stop blowing your nose, right? Um, Sometimes it's allergies, but a lot of times it's just irritation from all that dust and grime getting breathed up and in. That's why people who work in really dusty scenarios uh, often wear special respiratory masks that are a little bit more heavy duty than the ones we are wearing to kind of protect them from that particulate matter. But these do definitely help. Um, Over time, repeated exposure to this kind of stuff can lead to things like asthma, bronchitis, or emphysema. So we can actually see, I believe, don't quote me on this, but I'm pretty sure we can see like an increased correlation in children with asthma in big cities where they're exposed to lower quality air than in a rural area. But I'll have to find the scientific research to back it up. But people who work in factories that can be really dusty, or things like coal mines, or stuff like that, um, where they are constantly breathing in air pollutants, uh, can have severe respiratory problems. So this is usually with particulate matter. So when we talk about particulate matter as a pollutant, this is how it affects us. The next one is carbon monoxide. So our blood cells have a special protein in them called hemoglobin. Hemoglobin is the protein in our red blood cells that holds the oxygen and takes it where it needs to go. Now, carbon monoxide is just one carbon and one oxygen. So it's just an oxygen molecule attached to a carbon. And hemoglobin actually prefers carbon monoxide. Hemoglobin will drop an oxygen and trade it in for a carbon monoxide because it's easier to bind to. So, whenever you inhale carbon monoxide, your hemoglobin will bind to that carbon monoxide and start carrying it around your body. But your body can't use carbon monoxide. Your body needs oxygen. And without oxygen being carried around by your hemoglobin proteins, this can cause headaches, tiredness, nausea, heart damage, or even death in severe cases. This is why we have carbon monoxide detectors in our houses, because carbon monoxide is a colorless, odorless gas that can cause severe damage. There have been reports of people who have hallucinations in their houses because they have just low levels of carbon monoxide constantly, because their bodies are literally undergoing oxygen starvation without them knowing it. So if this is in the atmosphere, right, and inhaled by people, it can decrease the ability for a person to get the oxygen they need to survive. Um, so carbon monoxide is very, very dangerous, which is why, as an air pollutant, it's one of the big bads, right? So, uh, if a factory or something is emitting carbon monoxide, it can be a really big deal. Car exhaust was a very, very important, or not important. Car exhaust was a very, very big source of carbon monoxide air pollution until the 1970s, which I'll talk about how they tackled that tomorrow. Um, but yeah, carbon monoxide affects the body's ability to carry oxygen. And finally, air pollutants can contribute to cancer risks. Um, you just need the first sentence, you don't need to write down the example. But as an example, benzene is an organic compound. I believe is like shaped like that. Benzene is an organic compound um, that is released from cars and trucks in exhaust, and has been linked to some lung and throat and mouth cancers. So, people who work with cars, specifically old cars, like pre-70s cars, have to be careful with the amount of car exhaust they are exposed to, because benzene, while it isn't like a if you inhale this you will get cancer kind of thing, it does up your risk a little bit. So, we will talk about the hole in the ozone layer tomorrow, but there is another way that this can kind of cause cancer. If the ozone layer is depleted, right, the ozone layer is what protects us from the sun's radiation. The sun's radiation is also a carcinogen. So without that protection, the rates of skin cancer will increase because the Earth's natural sunscreen um, is weakened when that stratosphere of ozone is depleted. Questions so far? Okay. Moving on to some specific pollutants, I'm going to talk about smog, not Smaug for my Lord of the Rings fans, but if you combine, it's literally smoke and fog. Like they ooh, combined, combined the words smoke and fog and got smog, um, which is an unhealthy mixture of air pollutants that can form over cities and nearby areas. So, as you can see, there's kind of a thick layer of this dense brown haze that can form over cities. Um, it's actually kind of interesting. During the first lockdown back in March, right? Um, over the summer, we started seeing way less smog in really, really big cities because people weren't driving everywhere, um, which kind of gave people hope that there is some reversal to this process. Um, but the more cars and the more industries that are in an area, the more likely it is that smog will form in that area. LA and New York and Tokyo and Beijing, I think, are the big ones when people talk about smog. Because there are a lot of people driving a lot of cars all in one small place. Um, Now, there are actually two different types of smog we're going to talk about that kind of form in different areas due to different processes. So, starting us off, we have industrial smog. Industrial smog isn't necessarily a big issue in the US now, but it was produced when soot combines with sulfur compounds and water droplets. So this kind of smog was really big in cities like London and New York during the Industrial Revolution. Um, but in a developed nation, you have some sort of governmental regulation that kind of limits the amount of soot and sulfur that it can be released into the atmosphere. Uh, so it is way less common in developed nations than it was 50 to 100 years ago. So usually the smog that you see in big cities is not industrial smog. Um, because industrial smog comes from like factory outputs and stuff like that. So, especially in areas where there isn't any regulation. The smog we see is called photochemical smog. Photochemical smog is a thick brown haze that forms when sunlight acts on certain pollutants, specifically nitrogen oxides and hydrocarbons. These are mainly emitted by the exhaust of cars and trucks. So, big cities, lots of people, lots of cars, lots of exhaust, photochemical smog. I'm not going to go into the specific chemical reactions that happen when the sun hits these pollutants. Um, but they are complex and interesting. Okay, one second to write this down. We'll move on to, I believe, acid deposition. Ah. Um. Okay. So, acid deposition. Uh, acid deposition occurs when pollutants combine with water, oxygen, and some other stuff in the atmosphere, and they can form acids that settle on the Earth's surface. Um, so when people talk about acid rain, this is what they talk about. We release things into the atmosphere that combine with other things, and that forms acids. So acids from acid deposition is considered a secondary pollutant because we're not directly releasing the acids, we are releasing the things that combine. Yeah, if that makes sense. So a little bit of review on what specifically an acid is. Um, so if you remember way back, we had a little chemistry introduction. We talked about the pH scale. Uh, um, so uh, the pH scale goes from 0 to 14. Um, if it is less than 7, it is considered acidic. If it is more than 7, it is considered basic or alkaline. So pure neutral, so pure water with no additives or anything in it, is sitting at about a 7. That is our baseline. Now, normal rainwater usually has a pH of about 5.6. So chilling in this area right here. Just slightly acidic due to the natural composition of the atmosphere. But anything that lower than 5.6 could be considered acid rain. This is mainly sulfur dioxide and nitrogen oxides that are released into the atmosphere. that interact and then create acids. Ooh, sulfur and nitrogen dioxides or oxides are mainly released through the burning of fossil fuels. And while we would like to think that if we are to burn fossil fuels in one specific area, that it is just going to be that area that is affected by the acid rain. But in all reality, um, wind carries that stuff everywhere. So if West Lafayette, right, um, emitted a bunch of pollutants, it wouldn't just be West Lafayette's fault, right? If Crawfordsville released a bunch of pollutants, it wouldn't just be Crawfordsville's fault. We would have kind of an entire spread out, or winds could push it one way or the other. Uh, which is why when it comes to global environmental issues, international and interstate interactions are really, really important because the actions of one entity will dramatically affect the actions of other entities. Um, what is the harm in all of this? Where does acid rain become an issue? Um, and it's a lot of stuff. Um, acid rain can kill trees both by actually eating away at the leaves, but also by increasing the pH of the soil. And if the soil pH or decreases, sorry, if the soil pH decreases, it could kill the tree that way. Um, it could erode the surfaces of stone buildings. So stone isn't necessarily a indestructible thing. Um, strong acids or a bunch of weak acids over time can kind of eat away at that. It can increase the acidity of lakes. Like I said, usually water's chilling at a neutral, if not slightly acidic pH. But if that pH were to increase due to the addition of more acids, it could severely harm plant and animal life within that lake. Um, acids can also interact with metals. So if acid rain gets into water pipes, right, that the metal in those pipes can be leached from the pipes into drinking water and contaminate water supplies. Um, there's a lot of stuff that acid deposition can cause. So as you can see right here, this was originally a stone statue, but over time, uh, just like the entire face was eaten away due to acid rain. Um, so the addition of acids just kind of wear away at the detail here. As you can see, you've got a pretty normal leaf right here, but as is exposed to more acidic situations, it can get tough and leathery or even erode completely. Real quick, I'm going to go back to temperature inversion. Because this is another issue. Um, temperature inversion, usually, right, as we go up in the atmosphere, we get cooler, right? The higher we get up into the atmosphere, the cooler it is. Why we see snow on the tops of mountains, right? Higher we get, colder it is. But sometimes a process called temperature inversion happens, where a layer of warm air gets trapped beneath a layer of cold air gets trapped beneath the warm air. And when this happens, our normal balance of pollutants and weather patterns and all that can be severely affected. Um, if that cold air is trapped beneath the warm air, the pollutants underneath that aren't going to move, right? So warm air moves faster, hot air moves faster than cold air. Um, So if a pollutant is released into warm air, it can disperse relatively easily. If it's put into a fast-moving warm area, that pollutant can spread out really, really fast. But if there's cold air trapped below that warm air, and the pollutant is released directly into that cold air, it's not going to move as fast. It's just going to stay. So um, this is what normally happens, right? We've got warm air, cold air, but if cool air gets stuck down here, all of the pollutants are just going to stay down here because they're not going to move as fast. So there's an exit ticket. Ooh, there is an exit ticket on Canvas. If you could fill that out for me, please. Other than that, tomorrow is our last day of notes for this unit. So it is the last day we will actually have to sit through me talking the entire class period, at least for a while. If you have any questions, comments, concerns, let me know. We'll talk about controlling air pollution tomorrow, have an activity on Friday, and review next week.